even elimination and E2 elimination. Even elimination is a unimolecular elimination, whereas E2 elimination is bimolecular eliminations. So let us discuss both of these over here. So if I take an example of even elimination usually occurs in tertiary alkyl halides, and E2 elimination occurs usually in primary alkyl halides. Or if it has to be happening in tertiary alkyl halides, then we need to have strong bases and high temperatures are required. Alright, so let us see. If we have an alkyl halide like this, now if even elimination reaction is happening, so what will happen is a carbocation will be formed. This bond will break down Cl minus Cl plus due to solvolysis, and we get a carbocation like this. We get a carbocation like this. And step 2, in step, this is step 1, formation of carbocation is step 1, and step 2 is elimination or deprotonation. It is carbocation formation. Carbocation formation is step 1, and the step 2 is removal of hydrogen, or it is deprotonation from beta carbon. Deprotonation. So this happens like this. If we had CH3, CH3, CH2, CH, something like that is there. So what will happen? The hydrogen will break down, H plus, carbon will get minus. So minus and plus will form alkene. We get the product as alkene in even elimination, and E2 elimination the product will also be alkene, and the reagents will vary, In E2 elimination we take example of dehydrohalogenation. Dehydrohalogenation. Dehydrohalogenation is the example of E2 elimination. This is E2 elimination. What is happening over here is reagents. What reagents we can use here? We can use any of the following reagents which I am about to mention. You can take either alcoholic KH, or you can take NaNH2 sodamide, or potassium amide KNH2, or you can take ethoxide with ethanol, or methoxide with methanol, or we can take up a bulky base as well you can have, right? Tertiary butoxide with tertiary butanol. Tertiary butoxide with tertiary butanol can also be taken. This is a bulky base. This is a bulky base. It is written as TBuO minus, O minus, and you can have potassium or sodium. So any of these bases could be used for E2 elimination. So what actually you have to remember these, okay? You have to remember. You have to remember what reagents do what. So these reagents do dehydrohalogenation. So you have to remember. So top three reagents or will give ZF alkene as major product. They will give ZF alkene as major product. Whereas fourth bulky base will give Hoffman alkene as major product. Alright. Because the size of the base is high, it will usually give Hoffman alkene. What is ZF alkene? ZF alkene is the alkene which has more number of alpha hydrogen, whereas Hoffman alkene is the alkene which has less number of alpha hydrogen. More number of alpha H, ZF alkene, less number of alpha H, Hoffman alkene. Alright. Now I'll show you. If I take an alkene like this, CH3CH, Then we take like this, we have, let's say, Br over here, and you have this CH3. Now, if I do dehydrohalogenation for this, we can have two products. We can have two products. If I take any of one, two, or third reagent, alcoholic KOH ethoxide or methoxide along with NaNH2, you get the major product as Br will be removed from here and H will be removed from here, and the product will be like this: CH3, CH double bond CH, CH3. So this has 6 alpha hydrogens. It is known as Serzephelkene. Whereas a minor product can also be produced where hydrogen is not removed. This is a alpha carbon and this is beta. Hydrogen is getting removed from beta carbon, that is why this elimination is known as beta elimination. If hydrogen was, this is also beta. If hydrogen was getting removed from this, the product you will get like this: CH3, CH2, CH double bond CH2. Alright, double bond will come this side. So this is a Hofmann product. In the reagents 1, 2 and 3, Serzephelkene is the major product, but in reagent 4, the bulky base tertiary butoxide, you will get Hofmann alkene as the major product. Alright, so it depends which type of reagent you are taking. This has 6 alpha hydrogens. Alpha hydrogens are hydrogens present on carbon adjacent to double bonded atom. So these are alpha carbons, 3 plus 3, 6 alpha hydrogen. Here you will have alpha this, so you will have 2 alpha hydrogen. So Serzephelkene is the alkene which has more number of alpha hydrogen. Hofmann alkene is the alkene which has less number of alpha hydrogens. In top 3 reagents, Serzephelkene is major, and in the reagent number 4, a bulky base tertiary butoxide, Hofmann alkene is the major product. I hope you could make out what are the consequences and how the reagent is acting. Since bulky base is taken, so bulky base approaches this carbon and takes hydrogen from this, because no steric hindrance over here. Whereas if bulky base comes to this point, it has so many groups around it, so it is not able to remove hydrogen from this carbon. So hydrogen is removed from this carbon in the case of bulky base tertiary butoxide, so double bond comes over here. Alright, so Hofmann alkene becomes major product in the case of bulky base tertiary butoxide. In all other cases, Serzephelkene is major product. Reactivity of all alkenes is depending on electrophilic addition. Now the formation of alkene, this is the method. Reactivity is for alkyl halides is 3 degree, 2 degree, 1 degree for E1 as well as E2. If RF, RCl, RBr, RI are present, then RI bond is more in length, so it is weak bond. So RI is more reactive than RBr, RBr is more reactive than RCl, RCl is more reactive than RF. So these were the points, and if you ask me in which of these intermediate carbocation is formed, I will say E1 carbocation is formed. In E2 there is no carbocation formation, only transition state. So that's it for now. Thank you.